Hi everyone. In today's lecture, we are going to learn about the experiment section, like what to write and how to write the experiment section, and organize the different subsections that are involved. This would basically be the section where you provide evidence for the claims you are making in your paper. There are mainly two parts involved. The first being the experimental setup, where we describe the datasets that we are using to benchmark our method in comparison with the other methods that are out there. We would discuss the baselines that we are using, for example, the methods we are comparing against. We would also discuss the evaluation protocol, like how are we evaluating our methods, like what are the metrics that are being used. We would also discuss the implementation details that have the model architecture, the training and testing details, which is optional in this case because we could also add this one in the supplementary material as well, which we're going to look at in the next set of lectures. The second part is the results section, where we compare with recent works. Here we would start off with a solid baseline and then apply our idea to it. And finally, we would do the comparison where we compare against a bunch of methods, showing how good or how bad our method is compared to those. We would also add the results of using different components of your method. For example, if your method has 2 or 3 components, we would test each of them in isolation, which would basically be the ablation study. Then we could add additional results like visualizations, robustness tests to basically back up our claims that we are making in our paper. To start off with the first section, which is the experimental setup. At the beginning, we would describe the datasets that we are using. So in this subsection, you would have what is the modality of the dataset. We would also cite the relevant dataset papers, how many samples the dataset has, what are the training, validation, and test splits. And optionally, we could also discuss how hard this dataset is. For baselines, we would briefly discuss the details on how the method works. You could think of this section as a really compressed version of your related work section, where we would just basically summarize what is the different category of methods that we are using to compare against our proposed method. After that, we would discuss the evaluation procedure, where we cite previous works that use the same process of evaluation. After that, we would discuss how it works and also what points to a good performance. For example, in mean intersection over union, the higher number we have means that the method is better. For example, if it's in a range from 0 to 1, if it's closer to 1, we would say that this is doing good. If it's closer to 0, we would say that it's not doing as good. This is to give readers an idea that, for example, if there's a new metric out there and a lot of people don't know about it, and when you refer to that metric in your table in the experiment results section, the readers would understand, okay, if two methods have, like, if one of the two methods have a higher number in this metric, this would be a good result, that it is better than the other. So it's to give the readers an idea on what represents a good accuracy. Here's a template for the experimental setup. The first thing would be the dataset details. After that, we would discuss the baselines and then discuss the evaluation procedure. The second part would be the results section, which would basically have the comparison with recent methods. Here, all the claims that you have in your paper should be supported by your own experiments or either by citation, which is possibly from previous work. You would also have the ablation study in case your work has different components involved. This section would also include visualizations like graphs, tables, and figures. And finally, there would be additional experiments. For example, it could be robustness or runtime analysis, etc. The results section could start off with the comparison with state of the art. Here I've written qualitative, which would basically show visual examples. And on the description for this subsection, you could discuss what is it, and then this would be followed by where do others fail, and then you would end the paragraph with some overall failure cases, showing patterns that different methods fail in these aspects. After that, you would add a new paragraph, which would basically talk about how your method is good and why is it good. For example, which components help in which cases. Like if you have two components, you can mention something like component one helps in problem X or component two helps in problem Y. This would give readers a better understanding behind the motivation of why you are using different components in your method. Finally, you could tie this to the main claims that you are making in your paper. And you would end this section with a summary of how good your method is. The comparison with state of the art would include another part, which is quantitative, where we would basically show the numbers in terms of different metrics. So here for this description, we would again start off with what is it and how much improvement we have in compared to the other works that we are using as baselines. And then we would add descriptions like, is it more efficient or is it more scalable compared to the different methods? And any additional insights that you would have while you did the experiments and when you compared with the previous methods. So those kinds of details would go in this part. You should also add figures and tables, which would show like visual examples or the numbers for different metrics when you are comparing against the other methods. So on the left, you could see here's an example of a bunch of different methods. And for 3 data sets on the mean intersection over union metric, the authors have added the numbers for each of the corresponding methods. So it's basically showing a comparison of their method against the previous methods. And on the right, it is something similar where we show visual examples of different methods and their predictions, which also includes the input image itself and the corresponding ground truth, which is what we want the predictions to be the closest at. And the figures and tables would also have the necessary captions, which would basically highlight the main takeaway message from that figure or table. Ideally, you could think of one table as a one takeaway message or one figure as a one takeaway message. So for example, on the right, the main takeaway message is that the method outputs better predictions in cases of variation in overall appearances and also very small and ambiguous regions of interest. For the ablation study, we would basically talk about what does the component address. For example, the claims that you are adding in your main paper would be directly related to the components that you're using. A simple example could be that component one helps in this specific problem. And for this description, we would add the evidence that shows that the component actually works. It could be a visual example, or it could be in terms of metrics where we show that when you're using this component, the metrics actually go up and gives you better results. And you could add a figure showing the different ablation studies for the component and the impact of performance it has in terms of metrics. Again, here, we also add the takeaway message that this figure is trying to convey. And it says here that the method consistently improves performance of various baselines in both binary and multi-class image segmentation tasks. Some other results include visualization of predictions. For example, you come up with a new model or an architecture, and you would want to visualize the predictions that it is outputting. This is to basically show that your method actually works for the task that you are trying to address. Same as before, this figure would also have a takeaway message, and which is in this case, the method is able to output better predictions for minority classes. So it's highlighting a single pattern that the model is being able to pick up on. You could also add runtime analysis, which would basically compare different methods and their parameter count or flops. Additional experiments could also include something like robustness tests, where you test different methods in different forms of corruptions to basically see how good or how bad the models are doing. Here's a template for the results section. It would start off with the comparison with state of the art, where you have one subsection for one data set or task. And for each of those, you would have the quantitative results as well as the qualitative results, where you visualize the method outputs. This would be followed by the ablation study of your method, where you show the contribution of each component in isolation. After that, there would be the analysis of method, for example, parameter tuning. And you could end with additional experiment results like robustness tests or runtime analysis. That's it for this lecture. And on the next one, we will learn how to write the abstract and conclusion sections.